Hello everybody, and welcome to example 4 on page 45. Okay, and this problem would like us to take the function y equals secant of x over c plus xe to the x and to calculate the derivative dy dx. Okay, now before we dive into this, let's make a few observations. First thing is, you might notice there's a c sitting here in the bottom. Okay, we're treating that c as a constant because of the fact that the derivative they're asking us for, dy dx, that is implying that y and x are the two variables in this problem. Anything else that we see is going to be treated as a constant. So we'll kind of keep that in mind as we're going through this. Okay, and then we have to ask ourselves, out of all the derivative rules we've talked about, which ones would apply in this situation? Let's look at this function as a whole. So secant of x over c plus xe to the x, what do you see there when you look at that? Okay, well, I see a quotient, a ratio of two functions, secant of x over c plus xe to the x, and to me, that says that quotient rule is where we're going to need to start. Okay, so let's do the jingle together here. So the quotient rule sounded like low d high minus high d low all over low squared. Okay, there's our first step. We've just used the quotient rule. And now the question is, what do we need to do to finish this problem? Well, there are two derivatives that we still have to take. There's one there, the derivative of secant of x, and then one here, the derivative of c plus xe to the x. Okay, let's do those one at a time. So we'll rewrite the c plus xe to the x. There's nothing to do with that part of it. We're done. What is the derivative of secant of x? Well, if we just scroll up here, looking at our chart, we said that the derivative of secant of x is secant x tangent x. Okay, and then moving on, we've got a minus secant of x. And then we come to the derivative of c plus xe to the x. Let's look at those pieces one at a time. Okay, so starting with c is a constant. We made that observation at the beginning of the problem. What happens when you take the derivative of a constant that's just by itself? You're just going to get 0 for that. Okay, and then we come to the piece that we have to be a little careful with. How do we take the derivative of xe to the x? Okay, well, notice that that is a product of two functions, x times e to the x. And so what that means is that we have to use the product rule to take the derivative of that xe to the x piece. Okay, so think of x as your first function and e to the x as your second function. And if we write out the product rule, it's going to look like first times the derivative of the second plus the second times the derivative of the first. Okay, and just for the sake of your notes, I'm going to mark that. Okay, that part that I'm bracketing there, that came from the product rule applied to just this small part of our problem, the xe to the x. Okay, and all of that's divided by the denominator squared. Okay, so c plus xe to the x squared in the denominator, that is. Okay, now, are we done or do we have more to do here? Well, notice we've still got a couple of derivatives to take. We need the derivative of e to the x and the derivative of x. If we can take those two derivatives, we will be done here. Okay, so probably one more step is going to do it in this case. Okay, secant of x. And then, let's see, so we've got x times, now we're ready for the derivative of e to the x. Derivative of e to the x is still e to the x, plus e to the x. And what is the derivative of x? Well, the derivative of x is the derivative of x to the first. That's going to be 1x to the 0, which is just going to simplify to 1. Okay, we've seen that a couple of times. Okay, and looking at that, notice that there are no more derivatives to take. We've gotten rid of all the ddx's, and so this is an acceptable final answer, what we have here. Okay, and maybe just one final comment. Just notice we actually use the quotient rule and the product rule on this problem. We use the product rule inside of the quotient rule, and so it illustrates that in some problems you might need to use several different rules. Okay, that's okay. That's when your function is complicated, you may very well need a couple of different rules.